So the inverse sine or arc sine function, we've placed our restriction on the sine function between negative pi over 2 and pi over 2 to give us something that has an inverse, and this is that inverse. That restriction then becomes the range of the inverse sine, and of course the domain is negative 1 to 1, since sine will never give us anything outside of negative 1 to 1. So these are just some key features of that graph. There's an intercept at the origin, 0, 0. It's symmetric in the origin, and because of that, it is an odd function. We can also look at the inverse cosine or arc cosine function. And for this one, we similarly place a restriction on the cosine function. And the restriction that's placed is between 0 and pi. And that becomes then the range of the arc cosine. In other words, if I'm doing the arc cosine of a number, it will always give me an angle between 0 and pi. Again, since the range of the cosine is negative 1 to 1, that's the domain of the arc cosine. And we've got a y-intercept at the point 0, pi halves. And then we have here the arc tangent or inverse tangent function. You can see that this looks kind of like the tangent function, again, just flipped over the line y equals x, okay? The restriction we place is between the two asymptotes, negative pi over 2 and pi over 2. And that restriction of the domain on tangent becomes the range of the arc tangent or inverse tangent. And because the tangent has a range of all real numbers, that's the domain of this inverse function. So this arc tangent function, because the tangent has vertical asymptotes, the arc tangent has horizontal asymptotes at positive pi over 2 and negative pi over 2. The arc tangent function also has an intercept at 0, 0 and is symmetric in the origin, meaning it's an odd function, just like the arc sine or inverse sine function. The inverse secant and cosecant functions, I'm not going to talk about them here because there's actually not universal agreement on what restrictions should be placed on the secant and cosecant functions. The cotangent function does have a restriction between 0 and pi, but we're not going to consider that one here.